Okay, in this video, I'm going to be introducing the roots of unity and how to use it to solve this problem. Okay, so I'm going to begin with a little pattern. Okay, so we know that x squared is 1 has two solutions, obviously. It's going to be, I'm going to plot this in the complex plane. You're going to see why in a little bit. Okay, it's just 1 and -1. If we have x to the 4 is equal to 1, we're going to have 1 and -1 again. But we're also going to have I and -I. And what's actually happening is that if we keep going further and further, we're going to keep making a circle each time like this. Making a circle. And even for the one shown here, z to the 8, they're all going to form a nice circle. Okay, so we're going to have the original 4 from last time. And some here in between each one. And the pattern goes on. And since these are equally spaced around the circle, what happens is you can actually use trigonometry to find each complex solution. So let's take this one for example, which is at 45 degrees counterclockwise. Okay, so since the radius of the circle is 1, it's a unit circle, the magnitude is 1, and we have a 45-degree angle. Let me draw it a little straighter. Okay, we have 1 here. And the same rules in the unit circle apply in the complex plane. Let me label that again. Okay, so this y coordinate, which is going to have an I, is going to be I times sine of 45. And since the x values are real here, what we would call the x-axis, this is simply cosine 45. And to get the solution, we add these two. So this solution that's 45-degree counterclockwise from the origin is going to be cosine of 45 plus I sine of 45. Okay, and that would be the solution where r is equal to 1. But in this one, since we have a different number here, we don't have x to the a is equal to 1. We have 6561. We're going to have to write this in terms of a new radius. And if you know your modular patterns, this is actually 3 to the 8, because otherwise this would be a ginormous number since it's an 8th power. It's going to start small like 3, 6, 5, and 6, 1. So that means our radius is 3. So we're going to repeat the same process, except for the one we have here, where we have 6, 5, 6, 1. We're going to multiply by 3. So 3 times cosine of 45 plus I sine of 45. That would be what the solution that is 45 degrees counterclockwise. Okay, and if we want to solve the problem, it's asking for the complex conjugate, so that would just mean turn this into a negative, and evaluating that would be 3 root 2 minus 3i root 2 over 2. And that would be the solution for the problem in question. But if you wanted to find all solutions, what you would simply do is keep going with the angles. So you would do 1, 4, 45, 90, 135, 180, and you just loop around the entire unit circle there. Okay. And it is also worth mentioning, if you write this a little more concisely, there's a notation called sysdata. So this above is also written as sysdata if you're studying the recent unity. Okay. So to answer the original question on the thumbnail, to find all complex solutions, you're going to do this same process, but repeat it for all angles up to 360. I hope this video helped.